Welcome to another exciting video lesson. Now, in today's video lesson, we are going to be talking about the untold IUPAC rule of naming compounds, especially hydrocarbons like the alkenes and alkynes. Now, there is an untold truth about the IUPAC nomenclature that is often missed by tutors and students that people hardly talk about. Now, in this video, I'm going to be exposing that secret to you. Now, take for example, this compound on the board. I had to get this compound to explain a particular thing, a particular rule. Now, watch this. If you look at a structure like this, for example, now you will know that the first thing that you quickly observe is that this is what? An alkene. It has a what? A double bond. So what we are going to do, the general rule, is that we are going to give the least possible number to the carbons carrying what? The double bond. All right. So now let us check. Now, first of all, identify your parent chain. Now, the parent chain is the longest carbon chain carrying the functional group, which is the double bond. The longest continuous carbon chain carrying what? The double bond. So now let's watch now. 1, 2, 3, 4, 5. Is that the longest? Okay, not really. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So we have gotten that the longest we can get is what? Hexane. All right. That is because there is a double bond. It is what? Hexane. All right. Now, so we're going to go. We can either go like this: 1, 2, 3, 4, 5, 6, or we can go like this: 1, 2, 3, 4, 5, 6. All right. But let's just go like this. So now we have gotten what now? We've gotten our parent chain. So those groups not part of the parent chain, they are called what? Substituents. So this is substituent. This is another substituent. Now, watch this. Let us number to give the least possible value to what? The carbons carrying the double bond. So when we are numbering, what do we get now? So 1, 2, 3, 4, 5, 6. Okay, but if you look at this compound very well, it looks like a symmetric. It is a symmetrical compound. All right, the double bond, from the double bond, all right, the number of carbons on the right is equal to the number of carbons on the left from the double bond. So if you look at this double bond, 1, 2, 3, 4, you have 4 carbons. From this side, 1, 2, 3 plus this one, so 1, 2, 3, 4, you have 4 carbons. So it's symmetrical. All right, but if you now count, if you number 1, 2, 3, 4, 5, 6, and you decide to number backward, 1, 2, 3, 4, 5, 6, what you will observe is that on both direction of numbering, your double bond is on carbon 3 and 4, 3 and 4 from both directions. So now you have gotten this from both directions. Here comes the tricky aspect that most people miss. Now, some people will just pick any direction because of any direction. No. Now, if you have numbered and you discover that from both ends of your number, maybe you number 1 to 6, then number from where you have 6, you start your 1 there again, back to 6, which is your 1 from where you previously started. All right. So when you observe that from both directions, they give you the same number. All right. So if you look at this, you have 3, 4, 3, 4. So from both sides, it means our double bond is in between carbon 3 and carbon 4. So that's the least number we can get on both sides. But now, how do you now know the direction to pick? Now, the direction to pick will now be the direction that will give you the least possible number to the substituent. The direction to go with is the direction that will give you the least possible number to the substituent. Now, watch. Here is 1, 2, 3, 4, 5, 6. So if you go with this number, starting your 1 from here, 1, 2, 3, 4, 5, 6, you discover that your substituent will be on 1, 2, 3, carbon 3, 4, 5, and carbon 4. So your substituent will be on what? 3, all right, and 5. That's all. So you have substituent at carbon 3, you have substituent at carbon 5. You number like this. But if you are coming from this pattern, so 1, 2, 3, 4, 5, 6. So 1, 2. You have substituent at carbon 2 and you have substituent at where? Carbon 4. So now 3, 5, 2, 4. Which one is smaller? It's 2 and 4. If you just add 5 plus 3, 8. 4 plus 2, 6. All right. So this direction is smaller than this. So it means we are using this direction and not like this. So it means that our number, the accurate number we will now use will be 1, 2, 3, 4, then 5, 6. So it means therefore we have two methyl groups, and these two methyl groups are in carbon 2 and carbon what? 4. So the IUPAC name of this compound becomes 2,4 dimethyl, 2,4 dimethyl. Now it means your double bond is in between carbon 3 and carbon 4. So like I have dropped in my previous video, all right, on YouTube, I have taught that when you have two numbers, that's the double bond is in between two carbons. If you have something like, let's say the double bond is in between 2 and 1, carbon 2 and carbon 1, so you pick the lower number. All right, so in this case the double bond is between what? Carbon 4 and 3. So now between 4 and 3, or 3 and 4, which one is smaller? 3. So it becomes 2,4 dimethyl hex, because our parent chain is what? Hexane. All right, hexene, because of the double bond. So it becomes hexene. So this becomes our final answer. Please, this principle only works if your forward and backward numbering gives the same number to the carbons carrying the double bond. Numbering forward give us 3, 4. Backward like this, give us 3, 4. So when it's like this case, then you now pay attention to the side that will give the least possible number to the substituent. Thank you very much for watching this video lesson. My name is Sir Maestro, and I'm going to be seeing you in the next lectures. Please don't forget to subscribe, like, share this video, and follow.